Well, hey there, everybody. It is time for Astronomy Daily Live. So, welcome, everybody. I've got a kid. Hey there, everybody. It's time for Did it again. Daily Live. So, welcome, everybody. Someday I'm going to. Stop. Someday I'm going to. Someday I'm going. There we go. All right, so I've got a kitty at the microphone here. Oh, there she goes. Okay, so yeah, I hope everybody's doing well today. Things are okay here. Cleared up this afternoon. It's actually pretty clear outside right now. Got that bright moon out there. Yeah, it's pretty nice. It's pretty nice. I hope everybody's doing well. I am running a little bit late. I have to hang my head in shame a little bit for starting so incredibly late. I do like to be on time. And having said that, however, I don't pay much attention to what time it is. So I don't know how that all works out, but it seems to. It seems to. So yeah, I just sort of go with it, and I seem to arrive at the correct time most of the time, actually, without no timekeeping piece of any sort. Just yeah, I sometimes I do it the old-fashioned way. There we are. Can I hear you? Or am I hearing me? Ah, that's me. Still hearing an echo. That's me. Yeah, I'm still hearing an echo, Bobby.
Sorry about that.
Yeah, that's kind of a bummer. That's kind of a bummer. But pop in when you want. That's fine. No worries at all. So come on in, friends. Let's forget about everything else and concentrate on the universe and what is going on.
Hey, what's up, Bunker Bill, Cosmic, Tom, Crystal Gems, Ottawada? What's up?
Cool. Everybody's in. So Atta, I've got to hear more about your event. I saw your post over on the Discord server, and holy moly, you had like 200 people looking at the sun through one telescope. Hey, that is extremely cool and probably extremely overwhelming. But yeah, good job. Yeah, very cool. That's that's what happens. That's what happens. If you weren't already, you very well may be on your way to becoming the center of all the attention, because yeah, I mean you're showing people something that for the most part no one's ever seen, right? No one's ever seen the surface of the sun, except for a few, right, who look or want to. And compared to population, that's a very small number. So pretty much anyone who looks at the sun is probably looking at it for the first time. So very cool. And yeah, it's a great way to do a little ad, and yeah, that I'm having a hard time imagining imagining 200 people though. That's a big. That's a, I mean that's like a major event. So pretty good, pretty good. Cheers. Got some coffee here. And I've got a fresh brew of dihydrogen monoxide tonight. I am really going for it tonight because, yeah, need to stay awake somehow. So this does it. This is a lot of bang for almost no buck at all. So cheers to the H2O. So Bobby, how's everything going over there?
Everything is fine and dandy. I just got done with the Voice Report a week on shortwave.
Okay, yeah. I just, and this is a bit of a tangent here. I'm not quite sure why Report of the Week is as popular as it is. I'm not.
Well, that's the thing. I don't know what his channel is and stuff, but I do listen to his programming.
Okay, yeah. He does a shortwave show on, I think, a number of stations, right?
Yeah.
Yeah.
But
yeah,
he's always adding and discontinuing, so it's a dynamically changing thing and stuff.
Yeah, cool. Yeah. He just buys time on a shortwave station. That transmits. I'm not exactly sure. It's like 100,000 watts or something like that. Yeah, he's got.
Just uploads them to shortwave stations.
Yeah,
and pays them the money.
Yeah, for the time.
And then when it's time, they'll just go ahead and transmit all throughout the world.
Right. Yeah. I guess I'm talking more about his YouTube channel. He's extremely popular. He's got over 1 million subs now. He just passed the 1 million subscriber point, and he gets tens of thousands, hundreds of thousands of views on each video, and I'm not quite sure why he's so why him. Not exactly sure why. So I mean, he's really, really smart. He's really polite and nice, and has a great sense of humor. Great sense of humor. It is dark and dry.
Now I did have like one of those revolution things that in 2018 you will have better listening opportunities when the Overcomer got off the air. But now that the Overcomer is back, we just don't see it. But I think next year, I think there should be like better understanding of seasonal propagation, so you can like move around and stuff, and then you might be able to find your audience.
Cool. Very cool. Very, very cool. So, Atta, I want to hear a little bit more about what your experience was. How did you handle that kind of crowd? And it sounds like
she posted that on the Discord. If you would have had scrolled up too.
Yeah, she posted a little thing, but I'd like to know exactly how she handled that many people, because that's a big crowd for any kind of thing like that. And I mean, word does spread fast in communities like that, for sure. So I'd like to hear a little bit more about all that. Were there any sunspots? I don't think there was. Did you? What filters did you use? You said that you used one at the front and then one at the eyepiece. Was the one at the eyepiece different, like a hydrogen alpha or something else? Yeah, do tell. Yeah, they had to get. They just had to get into line. Yeah, very very cool. But you know, everybody in line, right, is sort of watching the person looking, right, and the person looking is saying things like wow and oh and wow, that's amazing and all that. And so everybody in line is like, come on, come on, come on, come on. So yeah, that's great. That's great. Yeah. So you use the filter for the front, which as I said is, as far as I'm concerned, it's a requirement, because otherwise you could damage your eyepieces, you could damage any kind of filters that are on that side of the scope. So yeah, always put one out in front.
We're going to have Ashley do have a star party from you again with your telescope and stuff.
Oh, I don't know. I don't know. I've got to.
Or you just can't beat Fraser Kane.
Well, I was thinking of that, but it's not really that, because I think that there's room for, I would say, at least five to 10 Fraser Kanes, at least, right? I mean, doing that. I'll bet that they could draw a really big, excited, fresh crowd 7 days a week doing that. So, so me doing it, do I feel any kind of competition or anything? No. I don't want to be doing it at the same time, because that's rude, right? But, do it another time? Sure. But I've got to, since I'm using the webcam, I'm pretty limited in terms of what can be seen. Only the really, really, really bright stuff. I mean, really bright. So, looking at, even bright open clusters, right? Even that, you're talking, fourth, fifth magnitude stars for the most part. Usually fainter, right? I'm just talking about the brighter ones. Okay, yeah. I was just reading Atta's comment about the solar filter H something, H alpha. That's the hydrogen alpha filter. Hydrogen alpha is a wavelength. It's around 68, 65 angstroms. And this filter is very, very narrow band, right? So that means it blocks everything else out, right? It blocks out all the blue, all the yellow, all the orange, all of that, right? And all the darker red, right? But in a very, very narrow band, it lets that light through. And so when you're looking at the sun with a narrow band filter like that, features that you normally wouldn't be able to see tend to pop out. So yeah, if you were looking at it with the hydrogen alpha filter, did you see any kind of prominences on like the side of the sun? Probably not. Mainly because the sun has been pretty inactive in terms of sunspots and prominences and all of that. So, but Yeah, very, very cool.
I
Very
know,
cool.
like Tim was on earlier today, but Uncle Bill was there. I'm not sure if you caught it or not.
No, no, I didn't. I got the notification, but I wasn't home yet, and then I got home, and got to do the homework stuff. So bunch of chores that have to be done, and all of that. Cheers to chores. All right, well, cool. Well, Atta, I think you are on your way to having a pretty interesting experience. And look, if you were to charge $5 a person, you'd be getting $1,000 every time you do it. So think about that. You never know, right?
I don't know. You
You could
know,
you
going
could
back
don't.
to like the streaming media devices like Fire Sticks, Roku's, and stuff, I would have been if let's say like if I charged like maybe 30 for like Chromebook programming, and there are like so many people that may have Chromebooks, they don't know what's Chromebook programming, and all I do is I'll give them a little demonstration. I can always put it back to the way it was if they don't like it.
Hmm.
But when it comes to Chromebook programming, I can put a Linux system. So like let's say you want your Minecraft in Steam, you might be able to do that more on a Linux based system than on a Chrome OS based system. I've been hearing that Linux is coming to Chrome OS, but it's not going to be like all there yet.
Hmm. All right.
Like
Well,
the graphics
cool.
acceleration and stuff like that, they're working on graphics acceleration right now.
Yeah. Interesting. Very, very cool. Yeah. Open source is the way to go for sure. So yeah. So, um, Atta, yeah. Do what you're going to do. I think doing it for free. Obviously, to me that's a no-brainer. So I'm just letting you know what you're gonna miss out on. So, but you won't have the same kind of joy. It'll be a different kind of joy, because you're giving it away. So yeah, yeah, good, excellent, excellent. Now you just need to learn the sky a little bit, and that's that just requires clear skies, clear skies. So here's to clear skies. Cheers. Yeah, I got to tell you, Atta, in order to, I mean, it depends, but even with two telescopes, if you've got 100 people, wow, that's going to take a long, long, long time. So even if somebody just gets a really, really fast look, right? I mean, think about it. Uh, you know, 5 seconds a look for 100 people is what 500 seconds. That's well, I guess that's only like 10 minutes. But yeah, I mean, people want to look more than just 5 seconds, right? Let's do a minute, right? So then that's 500 minutes. Is that right? No, 100 minutes. So what is that? That's 100 minutes is an hour 40. So to get through everybody in an hour 40 for one look, yeah, it's that's definitely going to be a challenging thing. Definitely going to be a challenging thing. So hopefully they won't come all at once. So yeah, very, very cool. But yeah, if you have two there, then that sort of helps a little bit, right? So cool, cool. You'll do it. You'll do it. I know you will. And hopefully everybody will have a good time. So cheers. So I was playing with a little bit more Gaia data, you all may have noticed the video that I posted a couple of days ago showing the region around Messier 37, and what I did there is I just from the database got the proper motion in both right ascension and declination, and those values are in milli-arc seconds per year. So what I did was I took the current positions of all of these stars in a field of view, right? In this case, as I said, the region around M37, and I started with where they are now, and then
I guess Octolotto was getting popular too. You have looked at that last message.
Yeah, exactly. Yeah, I mean, 1.5 minutes goes by really, really fast when
Yeah.
you
And
know, you
I'm
never
looking
see.
forward to look at those T-shirts that you're going to have with that Star Sisters party, Anna.
Yeah, I think that's going to be very, very cool. So anyway, so as a starting point is just the positions of the stars now, and then I just did a linear motion on each of those stars based on their proper motions, which are designated in right ascension and declination. And I ran it for what would be 200,000 years, and then I ran it backwards, and then forwards again, backwards again. So I looped through forwards and backwards 3 times. And so it's kind of neat. You can see very, very clearly see that there are that there's this group of stars which are all moving together, right? And then there are other stars that are either not moving at all, or they are moving in some other direction. But for the most part, I think I chose that group of stars sort of on purpose. Um, um, choosing proper motions that sort of fell within a certain range, and so I picked out those stars.
Gaia, but did you look more of that Wise from last night?
Say that again, Bobby.
Not only that you was looking at the Gaia today, but did you look at more of the Wise telescopes last night?
The only things that I have looked at with WISE are what we did yesterday. Yeah, so haven't looked any more at that.
Yeah,
but
what, the next time we have objects of the day is not only look at the Sinbad, look at the HST, but also look at the WISE data.
Yeah,
see if WISE got it.
Yep, I think I think that is a very wise idea, for sure. Cheers to wisdom. So that video sort of looks okay and interesting and all that. Yeah. So then what I did is I just chose a random square degree of sky, and I think I looked at every star like 18th or 19th magnitude or brighter, right? In one square degree of sky, and I ran the same kind of movie, right? I've got the proper motions, and so I just apply those over time, and we can see where all these stars are going. And so here, let me share my screen, and I'll just run through these. And now bear in mind, this is just me messing around, right? It's not this kind of thing isn't like a done deal. This is just a work in progress. So let's see here. We sort this, and come down here. Oh, there they are. Okay, so I think I'm just going to play these. We'll see what they actually are here. Come on. And while that's running, I'm going to start up my smartphone here because I didn't do that.
Yeah, I think I saw that video earlier today. I've just looked at it.
A different one, right? So this, as you can see, it all starts in a little square there, which is a square degree of sky. And then I'm just running time forward. It goes 200,000 years into the future, and then it goes backwards 200,000 years to the present time. And then I just let that loop.
Mm-hmm. Interesting.
So, yeah, you know, it's kind of neat to see how the stars are moving. Now, this isn't going to be their exact motion, right? It's all I've done is I've taken the current proper motions and just done an extrapolation, right? I mean, I've just run this forward in time. Each step in motion here is 1,000 years. So some stars are moving through really, really fast, and so they sort of exit relatively early. But a lot of the stars, several of the stars, barely seem to move at all, which I think is pretty cool.
It's kind of a bit crazy that when it's present day like that, it's all organized. But when you put time forward to the future, you can see the disorganization coming into play.
Yeah, and actually, Bobby, that is your brain fooling you. See, because and I'm going to pause this right at the beginning, okay? What I've done, right, is I have taken, I'm going to start right there, okay? So what I've done, this is sort of the current configuration of the stars in the sky right now as I extracted them from Gaia, right? So this is a square degree. This is 1 degree on each side. So this is actually as chaotic and random as every other frame in this movie. It's just that this is the starting point. So it looks organized, but it's not. It's not. Just imagine that there's a bunch of other stars all around here, right? That are also going to be moving through the frame. But yeah, I mean, the effect is that this square spreads, right? It spreads out, which I think is pretty neat, right? I mean, it's a pretty cool effect. And it sort of looks like it becomes more chaotic, but it's not. It's not any more disorganized as when it started. It's just the stars are in different places. And as you can see, they're all moving in straight lines, right? So there's no...
You said this is like from now to 200,000 years in the future.
Correct.
Can you go further than that, or that's too far out?
I can go as far as we want. But the further out we go in time, the less likely that it's actually going to look like that, right? And that's actually what it's going to look like from, you know, from our location here on Earth. You know, the entire sky is changing. So here I just colorize them instead. Same movie.
I like the colorization effect.
Yeah, yeah. So those are just random colors. But as you can see, each star uh, is keeping its color, right? So as it moves, it stays the same color. So then I started messing around a little bit more. Let's see. Don't remember exactly what one this is. We'll find out. Come on. Okay, so this is just another colored one. Different colors, I think maybe a little bit slower. I know it's kind of hard on the live stream. It's
Hey, there's Tim Robinson right now.
Tim is in the chat. Cool. Hey there, Tim. We are looking at the motions of stars over a time period of 200,000
And
years.
I wonder. I neglected to tell you this, but during Tim's live stream, there were actually were requests for Jill to bring back the tech shows.
Oh, cool.
I don't think it's going to happen though. But you may never ever know.
Yeah. Okay. Well, we will see. So I don't remember exactly what else I did here. I know I started drawing lines, or not exactly lines, but paths. So is this going to run or what?
It's kind of crazy that we don't use ABI anymore, too.
Oh, I use AVI. I like AVI. So here's the same stars, just sorry, this thing is being a little slow. So that's the same stars, but it's just the paths now. So I don't really think
like
that's
a
all.
super difficult Mission Impossible maze.
Yeah, I don't know if that's too interesting though. It is kind of interesting that a lot of the stars are moving towards the upper left. I think that's kind of
Mission
interesting.
Impossible level 9,000 or
Yeah.
over 9,000.
But yeah, I do find it interesting that a lot of the stars are going in this direction, right? So yeah, there's that, and I don't really care for that. I made a.
I wonder if all geeks have to watch Emanate in order to be like a geek or a nerd. But I don't think that's not true.
I didn't hear all of that, Bobby. What'd you say?
I wonder if all geeks and nerds have to watch Emanate in order to be like a geek or a nerd, or that's like one of those urban legends and stuff.
Yeah, I don't know. Okay, this poor machine is trying to run this video. For some reason, it's having trouble. Not quite sure why. I'm going to pull up the chat. Okay, cool. Anime. Did it? I guess maybe I have to try to run it again.
Maybe you should try M-Player.
Yeah, I don't like this. I don't like the look of this. Our little machine is being taxed. Let me
Check your task manager.
Way too many tabs open. Yeah, let me kill some of these. Hanging up a little bit. Okay. Okay, yeah, so this is just sort of the same thing, but random colors instead. And again, I don't really find that incredibly interesting. It's okay. And it's really sort of hard to see the real effect on the live stream. So yeah, it's not too interesting either. Let's see, what else do I have here? This one I think is, if I made this correctly, I just made it prior to yeah, so these are the randomly colorized stars. And this is from a different piece of the sky.
Yeah. Oh yeah, by the way, Tim, all's well here.
Yeah, all's well, Tim. So this sort of makes them look like they're twinkling. And again, it's sort of hard to see on the live stream, but I think I'll probably post this one onto this YouTube channel, because I think this is moderately interesting. I'd like to play with the colors a little bit, maybe have them, I don't know, somehow more representative of something, right? Right now, they're just randomly flashing. And I'd like them to, for their color to, have some kind of connection, to something about that star. Not quite sure what, though. But you can sort of see this big bright one here is barely moving at all. But so yeah, just having a little bit of fun with Gaia data and trying to see, what looks moderately interesting. And yeah, this is moderately interesting. I think this is, let's see how many stars this is. I just grabbed it off of Gaia, so there's going to be a count there. So I guess that's going to be mag 16, and this is mag 16.
Now these are like text files, and then you just generate that into a movie, right?
Yeah, it's just, I mean, here's the process. Okay, what I do is I've got this text file, which is just it's just a comma delimited file, right? So each column here is separated by a comma, and each column is a different piece of data, right? Here is the right ascension in degrees. Here is the declination. Okay. Yeah, these two numbers are the proper motions in right ascension. There's the right ascension one, and here is the declination one, and then here's the magnitude of each of these stars, and there's 339 of them. So there are 339 stars in this. So that's 339 stars there. Okay? So then what I do is I run that data into a little Perl script, which simply takes the RA deck, the proper motion, and the magnitude, stores them in an array, and then see, what have I done here? Oh yeah.
Perl is better than you, or do you try like other programming languages?
Perl is really, really neat if you're like parsing text files. It's absolutely great for that. So then I just take the proper motion of each star, right? So for each star, there's a for loop that is going to go over each star, right? So I, in this case, the variable I has a value of 339 in this case. So y is going to go from 0 to 338, and then it's going to stop, right? So it's going to take the right ascension of the star, and then it's going to add the proper motion, which is just proper motion itself divided by this big, huge number here, which is going to convert that to degrees per year. And then x, in this case, is going to go from 0 to 200, or 199. And I'm multiplying that by 1,000. So x is actually my year counter. And it's going to go from 0 to 200,000. And I do that for the right ascension and the declination. And then I write that out to another file. And then down here, I'm just creating a GNU plot script, a big one, a huge one, to make each of the individual frames, right? So that movie is comprised of 400 individual images, right? So here's image number 5, right? There's 5. Let's maximize this. There's 5. There's 6. There's 7. Ding, ding, ding. And if I click through this really fast, you can see, that there it is. There's the movie, right? But it's just a bunch of individual JPEG images, which I then combine into an AVI file. So yeah, there's 400 here, from 0 to 399.
Hey,
Patrick in the chat?
Yep.
Cool.
Yeah.
Cool.
And I just had like a light pool in the neck as well. I hate that.
You got a what in the neck?
Like a little light pool, I just like lightly pull my neck a little bit.
Oh, yeah. Don't do that. I highly recommend against that. All right, well, cool. Let's.
It really, really hurts if you pull a muscle.
It does. It does, absolutely.
If you pull it too hard, you will be screaming bloody murder as well.
You'll be screaming for weeks. All right, I'm going to stop sharing. And let's see. What should we do? Let's do a. Why don't we start looking at a constellation and see how far we get? So let's do a constellation. Okay, so I'm going to just stop sharing my screen. Now I'm going to share my screen again. And let's take a look here. All Oh, I don't remember how I'm doing this. I lost my train of thought again, Bobby.
Yeah, it was looking like you're about to do a constellation of the day.
Constellation of the day. Man, there are too many things on my mind. Okay, here we go. So there's a list, the list of the 88 constellations in the entire sky. This is an alphabetical list. All right, it's got them all there. 88 of
I'm
them.
looking for what are some of the great apps you can have on Android that are Stellarium-like.
I don't know. You know, there's a lot of great apps out there. So yeah, find one that you like and stick with it. Let's see. Okay, so we're going to go over to random.org as well. Let's see.
I want to know how long Landon.org's been around. I remember using it back in the 2Ks.
Yeah, I think random.org has been around for quite a while.
Probably since the dawn of the internet.
Yeah. So we're going to have it choose our constellation of the day by choosing a number, an integer.
I just hope that random.org never dies.
Yeah, we'll never have any way of generating random numbers.
That dies, we're gonna have a little problem.
We're gonna have big problems. Big problems. All right, let's do it. Number 62.
No,
right,
we're using Google Hangouts, Patrick.
Pegasus. Yay, Pegasus.
Pegasus. We probably might see Atlantis. No, like in Stargate Atlantis.
Constellation. Pegasus is a big constellation. Monster. One of the big ones. What does it say? 1,121 square degrees. Yeah, that's big. That's really, really, really big.
And Altalana is correct about the internet before the internet. There was internet before the internet.
Oh yeah, that goes all the way back to the 60s. Easily. So there it is, outlined there. There is the current border of the constellation Pegasus. So as you can see, what's that, Bobby?
And it's kind of like a bit funny about the computers whenever they first made their presence known. About how highly priced is like one of those computers, and to access other computers, you got that little ding and a headset telephone. You dial into the computer. Once you get a tone, you put the headset into that modem, turn it on, and you're talking to a computer from another computer. Just like you remember War Games, right?
Oh yeah.
War Games is a great example.
Yep, exactly. Yeah, that's one way for computers to communicate with one another. The military had ARPANET and a couple others, and those were pretty much hardwired. But yeah, that goes all the way back. The internet goes. That idea. I think sort of goes back to the 60s.
If you did check the chat, they were talking about how our computers were great back then, or whatever.
Bigger than houses, yeah. Yeah. Hey, since we're diverting on that. Hold on one sec. I'm going to grab a couple of things. Since we're doing the computer reminiscing thing, I'll just show you. I gotta get out of this. Stop sharing. And so this was my first computer. I got this, I think about 1982. So that's a Timex Sinclair ZX81.
And you said one time that computer still works, right?
This computer still works. Still works. And I actually, now I'm going to try to focus. There we go. So I learned BASIC very quickly, but I could not comprehend machine language. I didn't know how computers worked at all, right? So the little bit of information that, and actually it was an adequate amount to actually do it, but this head is really thick, really thick. And so comprehending how a computer works would have really helped me to be able to write machine code for this. So I never got into the machine code. This has 1K of memory. That's all it has. That's all it has is 1K, and I think it does have separate memory for BASIC because it does have, it comes installed with BASIC. When you turn this thing on, what you get is a little prompt, and it's all you can do, more or less, is start writing your program. So yeah, but I never got into the assembly code on this. There's a little expansion port in the back for expanded memory. And at one time, although I don't think I have this anymore, and if I do, I'm not quite sure where it is, I do have a 16K expansion pack, that sort of slipped on here. So
how do you connect this thing to like little television monitor and stuff?
Yeah, it's all right here. So it's just I think this is composite, and it's not gonna.
Where do you plug in the power at? Oh, there's the power.
Yeah, there's the power right here. Well, power right here, and then how you stored and saved and loaded programs. You did it on a cassette tape, right? So you've got an ear, and a mic. So this is the output. This is the input. You plug that into your tape recorder, and that's how you save and load programs on cassette tape. So yeah, very cool. Very small, right? I mean, really small. It's got a Z80 microprocessor in it, which is an incredible processor. I mean, even today, it's absolutely amazing, and it's everywhere, right? Then after a couple of years, I was able to upgrade to this guy, which I'm just going to keep in the box. So again, I stuck with the same brand, but this is well, it has 72K total. Some of that is used for video. Some of it is used for this and that. So I think in the end, there's something like 36K or something available for programming or whatever, right? But this is color. Yeah, it was a great step up. But again, I could not comprehend. In fact, I never really even thought about how these things worked. So I could never grasp, doing any kind of machine code, which I really wanted to do. The other thing that sort of bugs me about these is that, while I was just writing programs in BASIC, I was writing a lot of programs, a lot of them, a lot of games, a lot of, in fact, one of the first programs I ever wrote on this was an alphabetizer. So in one of the classes I had, right, this was grade school still, we got a spelling list every single week. And pretty rough teacher, he would give us maybe 50 words, right, that we would have to alphabetize and then look up the definitions and all that, right? And so it's like, you know what? I'm going to see if I can get this computer to do the alphabetizing for me, right? So I wrote a program to just do what's called the bubble sort, and you got to type in all the words, right? And then you hit go, and it sorts it, right? Worked really, really well, and I thought about it a while, and it's like, is this cheating? Am I cheating by, having a machine alphabetize a list of words that I'm supposed to be alphabetizing? And so I talked to him about that, and what he said, rightly so, is that I know how to alphabetize better than anybody else in the class, because I figured out how to tell a machine to do it. And if you can tell a machine how to do it, then you really know what the details are in terms of what's going on in our head, right? So yeah, that worked out really, really well. And once again, the kids hated me for that, because they thought I was cheating. But
Weird.
I knew more than they knew. So, well, it's the same story with the slide rule, right? The slide rule story where we weren't allowed calculators. So I'm like, okay, well, I've got a slide rule. I'm gonna bring that in. Basically the same speech. It's like, if you know how to use a slide rule, then you have a pretty good understanding of what multiplication actually is, right? What it actually is. And that's what a teacher likes, right? So yeah, I was allowed to use a slide rule. I was allowed to use my program because I actually learned more that way, a heck of a lot more. So yeah, just very, very cool. All right. Anyway, yeah, I've still got it. It still works. And right, the other thing that I wanted to say is that I was writing all these programs and it never, ever, ever dawned on me to sell them at all. But I have absolutely no idea. But I think I probably could have made a fortune because I was
I don't
running
know how much those computers can cost now on eBay.
these things.
Yeah.
I don't know. I don't know. I remember I mowed a lot of grass, and I raked a lot of leaves. I think when I bought this, I think this was $100. It was $100, and that was a lot of lawn mowing, and a lot of raking leaves in the fall. But yeah, I got it. And well worth
Map
it.
shenanigans at the chat.
What's that?
Map shenanigans at the chat.
I have to look at the chat. Wow, it's just mayhem. It's just absolute mayhem. So, do I still own the first thing that I ever bought? Nope. I don't think so. No, I'm actually I keep a hold of certain things, but most things I definitely let go. When they're done, they're done. Yeah. But these, as I said, I think these things might have a future, right? Because I have an unfulfilled desire to do some assembly code on these guys. So I just have to be motivated to do it. Because of course now I know how. So yeah.
Madness.
Yeah, Tim, these are just all music CDs. Yeah, I had my collection in like one of those books, right? And whenever I wanted to find one CD, right, I'd sort of have to page through them all, even if it was alphabetized and everything else, or sections, whatever. Right? I always had to page through all this stuff, and it's like, you know what? I don't want to have to page through things. So how am I going to do this? And it's like, just hang them on the wall. And then I can just walk over there and scan it, right? I can just scan it. So yeah, I've got CDs on this wall and on this wall that goes all the way over here. And then those. Yeah. It's just a nice, I think it's a nice way to decorate a wall. So yeah, wall-mounted CDs. Yeah, it just takes a little bit of time, to measure everything out so they're evenly spaced. That's easy. Just use a level. And yeah, my taste in music is all over the place. All over the place. Nothing wrong with being out of touch. I wish I was more out of touch. All right, let's start taking a look at Pegasus. As I said, it's a big constellation. So these are lines of declination, right? So 0 degrees declination is actually the celestial equator. And it goes up by degrees, right? Up to, wow, about like 36. So from maybe 4 degrees up to 36 degrees. So that's a lot, right? And it's about the same number of degrees across, right? At the celestial equator, right? Each hour in right ascension is 15 degrees wide. So from here to here is 15 degrees, right? Because we're going from 23 hours back to 0 hours. So this is almost 45 degrees wide, right? And at its widest, it actually is, right? So 45-ish degrees wide and 32 degrees high. It's huge, right? It's an absolutely huge constellation. And the easiest way to find it is to look for the Great Square. These 4 bright stars right there. And I think the Great Square, yeah, is it's not quite visible.
Why are you not sharing your screen?
What's that? Oh, I'm not. Oh, okay. Yeah, I need to. I meant to share my screen. I'm going to do it now. There we go. Sorry about that. Anyway, so absolutely huge, right? And pretty easy to find the Great Square, right? It's big. It's big. It's, well, as you can see, it's about 15 degrees high and about 15 degrees wide. So, yeah, not really visible yet in the early evening. You got to wait till maybe, oh, I don't know. You'll be able to see it by 11 o'clock at night or so this time of year. There's the great galaxy Andromeda right there, M31. And there's a bunch of nice objects in Pegasus. Mostly galaxies, but yeah, there is a globular cluster here, M15. So yeah, let's lots of stars, lots of objects, lots of binary stars. Yeah, this is absolutely packed. And NGC 7331 is absolutely gorgeous galaxy, absolutely fabulous. So yeah, let's take a quick look at Pegasus, just sort of what Wikipedia has to say about it. I also want to look at Burnham's, but maybe we can save that for tomorrow. So yeah, Bayer designations. Cool. Yeah, we're going to have to go through these because, as you can see, it's a bunch of, I guess you'd call them interesting stars. I'll go through this a little bit in advance. But yeah, let's spend some time again here. Spend the next day or 2 or 3, whatever, however long it takes, and sort of go through a few of these. And see what we can find out. I think there's, there's quite a bit here, for sure. And we'll be able to find a lot more, too. Yeah. Let's see, this is a picture of it up in the sky. Really hard to see. That's no good. Whoop. Let's see, does it say anything else interesting? Main stars 917. I'm not quite sure what that means. So they've identified 12 stars to be having planets. That's kind of cool. There's 3 stars within 10 parsecs of us. 1 Messier object, that being M15, right? Is that, yeah. M15 is a fantastic globular cluster. Let's see if whoop, I always do the wrong one. Want that one. No, we don't want that one either. Which one is it? I have to bookmark it. Huh, I don't see it here. How did I get to it before? Oh, here. Is this a different one? No. How did we get to that before? Never remember.
Did you put that link in the Discord?
Yeah, I don't know. Did I? Let's go look. Let's go look. See, I forgot to do my Discord thing here. I guess I'll do it now, but it's too late. Let's see, where would I put it? I think I would have put it... There it is. There we go. So we'll just check out M15 really quick with
I told you to
Wise.
bookmark it.
Yeah, I need to bookmark it. Let's go arc minutes. And we'll go full frame. So overexposed. Which one of these should we look at? So there's our target here, but yeah, pretty overexposed.
Yes,
so,
I am on Discord. I am Master Player 30.
Master Player 30.
And if you was on Twitch, I'm Master Player 301.
I can say for certainty that M15 is definitely an object that you want to look through your telescope, for sure.
And good night, Tim, by the way.
Good night, Tim. Thanks for coming in. Pretty late over there. Wow, 601. $2013. Well, let's see. There it is. Yeah, M15 is definitely worth looking at through a scope. Super easy to find and fantastic. Yep. Really nice. And of course, this thing has been looked at like crazy. I guess it's also called NGC 7078. Could be. I'm not too familiar with this instrument, the COS. Let's see what... So obviously it's a spectrum in the ultraviolet. So yeah, those are pretty short wavelengths there. Okay. So that's COS. Here's with pick 3 again. And 15 second. Okay, it's sort of off frame. Looking for something. Looking for something out here, some kind of population. Can actually look at the proposal abstract. Recent HST imaging of NGC 2808, which discovered that its main sequence is triple, with 3 well-separated parallel branches. Huh. Yeah, so they're just looking for stars, right? So they don't want to be necessarily looking in the core, because there are too many. They're not going to be able to pick out the individuals, right? But here, you can pick out the individuals really, really well and get yourself a good sample. So cool. Let's see. So it looks like they looked at it at a wavelength of 3922 angstroms, and which is really towards the ultraviolet. That's still sort of visible, I guess. But then they also did an infrared shot too. Let's see what that looks like. And then we should probably exit these waters for now. Okay. Pretty nice. Wow, that's a very zoomed in image. Amazing how well a space telescope can track, right? I mean, they're putting stars on, 2 or 3 pixels. It's pretty good. But you can see, the diffraction pattern here. Yeah. Not seeing anything else, right? They're not really seeing any background galaxies or anything else. We're looking at stars in the cluster, and stars that are in the foreground, and stars that are in the background. And that's about it, right? I'm not seeing. There's maybe kind of an interesting pattern here. I don't know if that's something actually out there or if it's something on the camera. Kind of hard to tell. But yeah, I'm not seeing any background galaxies or anything. That might be. It's a pretty short exposure, is it? No, not really. 2,093 seconds long. Nothing to sneeze at. All right, well, cool. Yeah, M15 for anybody's telescope. Yes. You can see this with binoculars too. So yeah, take a look at that. It's a fantastic. It's really big and easy to find. All right, you guys, I'm going to get out of here for now. I'm going to stop sharing. And I'm going to wish you all a good evening or a great day. And yeah, if you haven't yet, subscribe, hit the notification. But I am here every single day, 2 hours UTC, just having a fun, casual get-together of friends, sharing a passion, right? Not necessarily trying to teach or communicate anything, just sharing a passion, which is the science of astronomy. So very cool. We will continue with Pegasus probably tomorrow. So, all right, everybody, I'm going to get out of here for now. I will see you later. Cheers.